Hello, everybody. My name is Jorge Juárez from the Instituto Nacional de Astrofísica, Óptica y Electrónica, and I present to you this work based on the image segmentation. This research is developed in the area of image analysis of SDS polyacrylamide gel electrophoresis. This process allows to get an image of a matrix of data. The vertical lines are different experiments or sample of cellular extracts of different patients, and the horizontal spots are the bands that represent different proteins per sample. In this case, the human GPM is located between 25 and 37 kilodaltons. Before to perform the image pre-processing necessary to identify if the columns line of the total extract have a high concentration of proteins, or if so, then is necessary to make equalization of the histogram, or if not, only is necessary to make an image dilation, color inversion, and finally an image erosion. The images are resized to 600 times 400 pixels, and a max of 1 times 400 pixels is applied to cut the original image. The O2 segmentation is applied to the arrangement data of the histogram, and the last pixel is used to detect intensity value in white color, and the finally profile of the last value of the histogram of the complete image was plotted. For the band detection was used the same methodology, only the size mask was changed to 1 times 50 pixels. I show the first part of the algorithm proposed correspond to image digital processing previous to the feature extraction. This is the second part of the algorithm applied that correspond to the feature extraction to detect first lines and later the proteins bands. Now I show the results obtained. This SDS page image of the samples used to apply the algorithm is in this form. In the first line is the ladder, and the columns 2, 3, and 4 have the concentrate samples. The columns 5 to 15 are the purified samples with less contaminants. In figure 7 show the treatment of the digital process images. In A is the grayscale conversion, B is the histogram equalization, C is the inversion of the colors, and finally D, the erosion of the image to obtain an image without background noise, and the algorithm proposes can identify the separation between columns or lines. In the figure 8 is applied the algorithm that includes a mask in a short region to the image. The normal histogram detects the different gray color of the image. For that, the O2 segmentation saturates the image and separates only the black and white colors to get the maximum level or white color to be plotted. In figure 9, I show the analysis of the different regions applying the methodology proposed. Now, we can use a threshold at the intensity profile to find the different lines into the gel, and doesn't matter if the sample is concentrated or not. This methodology can detect if the protein is overexpressed or if has a low expression, changing the threshold value. The same methodology was applied to each column and to the ladder to identify the band's position. Each peak founded in the intensity profile corresponds to each band into the lane of the gel image. So we use the ladder to calculate the molecular weight to create an array to make a relation between the band position with the molecular weight. With the array of data, we apply the cube and Lagrange and linear and nearest interpolation methods, and we use the GPM protein that has no way to measure the total error at the moment to the method calculate the weight molecular of the band. So with this methodology, we find the best correlation of the interpolation methods used. Our results show that linear interpolation has less error than the others, with only 3% of the error, an accuracy of the 97%. So our method can find the molecular weight of the proteins inside into the lines. These are our conclusions. The methodology proposed can first detect the column of the different experiments inside of the EDS page gel. Second, we can detect the band of the different proteins inside of the each lane that correspond to different experiments. 3. Use the ladder to create an array between the band position and molecular weight. And finally, we use a different interpolation methods to the array to calculate the molecular weight of the proteins in the lines, and we found that the linear interpolation has shown the better results. Thank you for your attention. Please contact if you have any question.